All right. So like I said, we're just going to have a really short problem up here. When you first walk in, it'll be pre-printed on that paper as well. On Fridays, you'll turn these in. It's easy peasy points. Most of the time, we will walk through it, not every single time, just because sometimes we need the time. Other times, I want to make sure you're doing it, not continuing to stare at your phone and waiting for you to talk through it. Because that's kind of the point. All right, so what we're doing on this one, because I know we didn't have tons of time to look at it, is we are going to either test these values to see if they're true. You can substitute them in and see if they work, or you can solve the inequality. That's another fine option. Since we've already worked with inequalities a little bit, I hope that's something that makes sense to us, but not always, and that's okay. So if we were looking to solve this guy, this first one, what would we need to do? How do I get that x by itself? By? Close. -2. When we divide by a negative number with an inequality, what happens? The sign changes direction. So our values that are x is less than or equal to 3. So from this set of numbers, the ones that work are going to be 1, 2, and 3. You can also plug them in. 1 times -2 is -2. -2 is bigger than -6. 2 times -2 is -4. -4 is bigger than -6. So you can test them either way. On the second one, we need to get all of our terms together. I need to get my x's together. I need to get my numbers together. So what do you want to move? Which one do you want to move? 5x or 3x? The 3x. If we move the smaller one, we wind up with less negative numbers, and we really like that because negatives are annoying. So we're going to minus 3x from both sides. It's going to give us 2x minus 1 is greater than 7. That's a weird 7. There we go. If we add 1 to both sides, 2x is greater than 8. So what does x have to be greater than? 4. So of our set of options, what works? 5. Just 5. Only 5. 5 is the solution. Because x equals 4 is not an option. Has to be greater than. Take a look at this one here. What's our solution here? X is less than or equal to what? On the bottom one. 3. So our solutions that work, 1, 2, 3. So we're just going to kind of do little things like this. It's either going to refresh us with something, give us a little bit of extra practice with something. We may use it for review stuff. We may start to push ourselves a little further, that kind of jazz. It's never going to be super duper long. Just a way to kind of get us cruising and give you something to do right when class starts. And then we're going to get into notes. And today we're going to talk about solving absolute values. So get your notebooks out. All right, we have worked with absolute values before. We've graphed these dang things. These are the ones that are the V-shaped graph because absolute values are V-shaped, and I'm really bad at drawing them by hand. What absolute value is, and the way we're going to think about it, is our distance. Ooh, that's weird. Here we go. The distance from 0. How far? How many steps? Think of it as my Apple Watch. How many steps from 0? This makes our V-shaped graphs. We're not going to be graphing right now. We're just going to be solving. But those V-shaped graphs that we drew. Hello. He is not here.
Okay, thank you.
It's those V-shaped graphs. I was in the middle of writing that one. We got knocked on. And the way we are going to solve them, these bottom 5 words, I want you to write them in this order. Isolate, split, solve, check. These are our steps we're going to follow. Isolate means we're going to get the absolute value by itself. Isolate, we'll get the absolute value by itself. Then we're going to need to split it into 2 cases. So, for example, if we have the absolute value of x is 2, it could be that x is 2, or it could be that x is minus 2. So that's what we mean by cases. 2 is 2 steps from 0, and negative 2 is 2 steps from 0. Are 2 cases. Then we are going to solve each case. Solve each. And then to check, we plug them in. And yes, you have to check every time. For the absolute values, we always have to check. We're going to be using these steps throughout the course of the whole day and tomorrow. And I think the day after. No, not the day after. Today and tomorrow for sure. Okay, so we're going to start working with them. And I've got my isolate, split, solve, check up top. These are the steps we're going to take. Isolate, split, solve, and check. So we're going to start with this guy. Our first step is going to be to isolate my absolute value. I need to get the absolute value bars by themselves. Absolute value is a teeny tiny jail cell. We cannot put things into or out of the absolute value bars until after we split. Only move things outside. Do not play games with stuff inside. So if I need to get rid of that 2, let me bring it in here. What can I do to get rid of that 2 that's in front of the absolute value? Now subtract. What happens? What operation is it right here between the 2 and the absolute value? Multiplication. So how do we undo that? Divide by 2. Let me move it back up so we can see our words. There we go. I'm going to divide both sides by 2. So we're getting the absolute value of x is 3. So we have isolated. Then I need to split it. where this piece either equals this exact value, because my x could be 3. I'm looking for things that are 3 steps from 0. Well, 3 is 1, 2, 3 steps from 0. What else is 3 steps from 0? Negative 3. So x could equal negative 3. Hey, hey. Thank you, sir. So we've split it. Do I need to do anything further to solve it? Nope, we have already solved it. Oh, that is chunky. Then we need to check it. We need to make sure this works. To do that, we're just going to plug it back in. And you can do that in a calculator. You can do that in your head. We can talk through it. If x is 3, absolute value of 3 is 3. 3 times 2 gives me 6. I checked it. Negative 3. The absolute value of negative 3 is positive 3. Positive 3 times 2 does give me 6. So that one works. We have 2 solutions here. We are going to have times when we have 2 solutions. We're going to have times when we have 1 solution. We're going to have times when we have no solutions. You do not have to write tons out about your check, but you do need to check it. And even if it's just that you draw the check mark. And I will show you eventually today what it looks like when it doesn't check. Questions on this first one? Yes, dear.
X was 4, it would be negative 4?
It'd be 4 and negative 4, yes. All right, same process here. We need to isolate the absolute value. So what are we going to do to get the absolute value by itself? Divide by 3. It's going to give us the absolute value of x minus 2 equals 12 divided by 3 gives me 4. Isolated. We have isolated my absolute value. Then I'm going to split this in 2 cases. So this chunk, I'm going to use a different color. This chunk, my x minus 2, could straight up equal 4. Those absolute value bars might not be doing a gosh darn thing. Or this chunk could be the opposite of that. So x minus 2 could equal negative 4. It could be that this is positive 4. It could be that this is negative 4. We have 2 cases here. I'm going to give us a little barrier because those 2 lines look real close together up there. That's just a barrier to keep our minds separate. So we isolated. We split. Now I need to solve each of these. So when we look at just these 2, what do I need to do to solve this side? Plus 2. Plus 2 to this side, plus 2 to that side of the equal sign. So we have x equals 6. What do I need to do to this one? Plus 2. Plus 2. This time we get that x equals what? Not negative 6. That is the negative 2. So there's our solve. Yes, dear. So it's always that you go on either side of the equal sign. Since we had to add 2 to both sides, that's negative 4 plus 2.
You can go either?
We're adding it to both sides. Because the only way I can do that is if I do the same thing to both sides.
How do you know when to add?
Oh, because we want to get x by itself. So anything next to x, we want him to kick out. We want him to go away. Then we got to check it. So we're not done yet. So we're going to take our x's, and if we need to write it down, we can. Where we take our 3 times the absolute value of 6 minus 2, and I want to know if that equals 12. 3 times the absolute value, 6 minus 2 gives us 4. Absolute value of 4 is 4. 3 times 4 does indeed give us 12, so this one checks. Same thing for the other side. 3 times the absolute value of negative 2 minus 2 equals 12. What is negative 2 minus 2? Negative 4. Absolute value of negative 4. Absolute value of negative 4. Without the hiccup in the middle this time. It's positive 4. 3 times positive 4 does indeed give us 12. So that one also checks. So we have 2 solutions again. So this one and this one. That is a minus 2. I don't know what that shape is, but it is a minus sign. Questions on these? Because it's about to kick up a notch. Okay. It looks scarier. I promise it'll be okay. Still the same steps. Isolate the absolute value, split it, and solve. And check. Isolate, split, solve, check. So, I'm going to bring it in so we can see real good. I need to get my absolute value by itself first. So what are we going to do to get this chunk by itself? If I divide by 2 right now, I have a 17 and a 9 here. We're going to get fraction-y grossness. So what can I do first? Plus 9. So when in doubt, block off this side of the equal sign, because I don't care what's over here. I want him by himself. So we're going to add 9 first. And we get 2 times the absolute value of 5x plus 1 equals 4x plus 26. Again, I want the absolute value by itself. What do I need to do? Now we're going to divide by that too. Because that makes this 2 and that 2 cancel out. I do it as 2 separates. Divide this guy by 2 and divide this guy by 2. So we have the absolute value of 5x plus 1 equals 4x divided by 2 is 2x. And 26 divided by 2 is 13. Right? Isolating the absolute value. Now we are into our split. It could be that the absolute value bar is not doing a dang thing and 5x plus 1 just equals this guy over here. That's option 1. Could be that 5x plus 1 straight up equals 2x plus 13. Option 2 is that our 5x plus 1 equals the opposite of that. Just like we had 3 and negative 3, This would be 2x plus 13 and negative 2x plus 13. Note the parentheses I put around it. The opposite of the whole chunk, not just opposite of the 2x. These ones that have letters on the other side are very easy to get wrong because of this right here. Very, very, very easy to forget to put a parentheses around it. Questions up to there? Yes, and that's exactly what we're going to put on the next line, but I'm sure where it's coming from. Yes, dear? Because I need the opposite of this whole thing, not just opposite of the 2x. So it's got to be the whole chunk. Just like it was 3 and negative 3, it's 2x plus 13 and negative 2x plus 13. So we need the opposite of the whole thing. So then we're going to come in and we are going to solve each of these. Awesome. So what are we going to do to solve this blue one? Minus 1 on both sides. That's going to give us, okay, I get my blue back. 5x equals 2x plus 12. Keep going. Minus the 2x on both sides. Giving us 3x equals 12. Whew, and we're almost there. Divide both sides by 3. So our first option for a solution is that x equals 4. Whew, a lot of work. And that's only one of our solutions. We've got to do the other side as well. Our first step on our other option is going to be, a lot of you guys have talked about this already, to distribute this minus sign through. So we have 5x plus 1 equals negative 2x minus 13. It's important that both pieces are negative, or that both pieces are opposite of what they were. Then what are we going to do first? On this guy. Yeah, we can still minus the 1 on both sides. We get 5x equals negative 2x minus 14. Then what are we going to do? Add 2x. And we get that 7x equals negative 14. So x equals what? What are we doing next? Divide by 7. So we get x equals negative 14 divided by 7? Negative 2. Questions on the solving part? We still need to check it. Okay, for our check, I do highly recommend that we use like a calculator. because this guy is real long. We're going to have our 2 times the absolute value of 4. I believe. Oh, 5 times 4. Plus 1 minus 9. So 5 times 4 is 20. Plus 1 is 21. Absolute value of 21 is 21. Times 2. 42 minus 9 is 38. No, 33. And then our other side is 4 times 4 plus 17. 16 plus 17. Is 33. So this one checks. This is another way to do your check here, is to just take each side and simplify it down to a number. I plugged in 4 in place of this side of it and this side of it. Oops. No. Oh, it didn't get grumpy at me. Love that. Then we need to do our check for the purple one. Let's go a little darker. 2 times the absolute value of 5 times negative 2. Plus 1. Absolute value minus 9. So 5 times negative 2 is negative 10. Plus 1 gives us the absolute value of negative 9. Minus 9. Absolute value of negative 9 is positive 9. 9 times 2 is 18. 18 minus 9 is 9. And then we have to check the other side. Give myself a little bit more space. The checks are long, but they're doable. 4 times negative 2 plus 17. 4 times negative 2 is negative 8 plus 17 gives us 9. And since 9 does in fact equal 9, this one works just fine. Really, really long. Questions on this first one, or this first really long one? Okay. We're going to do another one very much like it. This is the last of the really long ones. Our steps are still the same. We're going to isolate the absolute value. Get that guy by himself first. What do we need to do to get my absolute value by itself, isolated? Plus x. That is an excellent first move. Going to give us 2 times the absolute value of x plus 1 equals 3x plus x gives me 4x minus 4. My absolute value is still not isolated, so we got to keep going there. What are we going to do next to isolate my absolute value? Divide by 2. Divide by 2. Divide by 2. And we get the absolute value of x plus 1 equals 2x minus 2. Isolated all by itself. Then we need to split it into our cases. It could be that my absolute value isn't doing any work at all and my x plus 1 does actually equal 2x minus 2. Or it could be that my absolute value is working its little tail off and my x plus 1 actually equals the opposite of 2x minus 2. It either equals this or the opposite of this. So we're going to bring it in, and we're going to solve this purple one first. What are we going to do to solve the purple one? Both valid options. Subtract x, and we can even do it at the same time. Add 2. Totally fine. If you want to combine steps together, that's totally fine. The x's are going to leave, leaving me with 3 on this side. Equals 2x minus x gives me x. If you want to start doing 2 operations on a line, you can absolutely do that. If you still want to make it separate lines, also fine. So we've solved that one. Let's bring this one in. First thing I'm going to do is I'm going to distribute that minus sign. So we're going to have x plus 1 equals negative 2x plus 2. Now what are we going to do? Use like you can add 2x to both sides. That gives us 3x plus 1 equals 2. Minus 1 on both sides. So we get 3x equals 1. Divide by 3. X equals 1/3. And we can do that. We can have fractioning answers. They're not always going to be pretty. So there's our solve. Next we need to check. I'm going to copy my thing down here. 2 absolute value x plus 1 minus x equals 3x minus 4. Just so I can zoom this in and we can still see it. Because first let's check that 3. It's going to give us 2 times the absolute value of 3 plus 1 minus 3. So 3 plus 1 is 4, absolute value of 4. So we have 2 times 4 minus 3, which is 8 minus 3, which is 5. The other side is 3 times 3 minus 4. 3 times 3 is 9, minus 4, also 5. So this one checks. So that one checks. We love that. Let's check the blue one. 2 times the absolute value of 1/3 plus 1 minus 1/3. So 1/3 plus 1 is 1 1/3 times 2 gives us 2 2/3 minus 1/3. So we get 2 1/3. When in doubt, use the calculator. The yellow calculator's second column, third button down is a fraction button, and it'll make your fractions look like fractions, and it can do operations in them. We love that. Let's check the other side. 3 times 1/3 minus 4. What is 3 times 1/3? 1. 1 minus 4. -3. Does 2 1/3 equal -3? No. So this is not valid. It has a special name I'm going to give you in a second. This doesn't work. We got something that's inherently false. 2 1/3 does not equal -3. Oh my gosh, look at all this work they made us do for something that's not even an answer. That is so extra. I promise there's a reason I'm using that. Because what this is called is extraneous. Oh my god, they made us do so much work. And it's not even an answer, it's so extra. Oh my god. Oh my god. Extraneous is going to be a word we use all year. And it's when we do all this work and we get a solution that's not really a solution. Oh my god, why? It's so extra. And I'm okay if you write so extra instead of extraneous. Like, that's totally okay. I have one more that I want to show you before we get to announcements. And we have time for it, I promise. Because it's super short. So this will be our last one for today. What do I need to do first here? Subtract 10 from both sides. So you have the absolute value of 4x minus 7 equals -8. Remember absolute value is how many steps it can take? I take -8 steps. If you get your absolute value isolated, has to be isolated. You cannot make the judgment earlier than that. If your absolute value equals a negative number, I cannot take negative steps. I cannot move in a negative direction. That's like inwards. I can't unstep 8 steps. So if you have your absolute value that equals a negative, no solution. We love that for us. Much less work. No check involved. No replugging. If your absolute value equals a negative, no solution. It doesn't work. We cannot have a negative distance because absolute value is talking about a distance. Okay? I'm going to pass out 2, 2. We are going to continue to work on that stuff a bit tomorrow, I think. Okay, so it's solving absolute values. There's a couple of story problems on the back, but they are very, very similar. I'm right, we're going to find a count for the math that's here enough 30 tops. All right. And